Here we are for the week 8 test. The first thing we're going to do, the first thing we're going to do is I'm going to remind you why you should go through this test. You should go through this because it'll help you to understand the concepts better, and it'll make you more prepared for the next test. Remember, every test has concepts for the new test plus the last couple tests. So when you take the week 9 test, there will be week 8 concepts. In fact, when you take the week 10 test, there will be week 8 concepts. So let's go ahead and get started. The first thing we want to do is we want to make sure we understand how these symbols translate into words, because we're asked to explain the relationship between each of these pairs using these 3 symbols. So the is equal to symbol, you all get the equal to part. This symbol is read as is less than. If the first number is the smallest number, we use this symbol because something like 2 is less than 5. This symbol is greater than. If the first number is the biggest number out of the 2, like 5 compared to 2, we'd say 5 is greater than 2, so we'd use this symbol. All right, let's jump into these. Negative 11, negative 15. Negative 11 is the bigger number, so negative 11 is greater than negative 15. Absolute values. We talked about the fact that defining these first, showing what their absolute value is, will help us. So the absolute value of 7 is 7. The absolute value of negative 7 is 7. So these are equal to one another. And finally, negative 6 compared to negative 4. Negative 6 is smaller, so we would say negative 6 is less than negative 4. On to part 2. They asked us to record these in a list that is least to greatest. And we talked in class about the fact that you can think of this, if you think of it in terms you use more often, it would be smallest to largest. What's the smallest number all the way to the largest number? Well, the smallest number in this set of numbers is negative 20. None of these are absolute values, so these are just the straight up numbers. So negative 20 is the smallest number. Negative 18 is the next smallest number. Then comes negative 6, positive 6, and the biggest number is positive 32. All right, moving down the page. Absolute values. We talked about the fact that absolute value is the distance a number is from 0 on a number line. In fact, let's just get that definition down right now. The distance a number is from 0 on a number line. There you go. The magic of pause just appeared. Poof. The distance from a number to 0 on a number line. So for each of these, when we're figuring their absolute value, the distance from negative 7 to 0 on a number line is 7 spaces. The distance from 13 to 0 is 13 spaces. The distance from negative 5 to 0 is 5 spaces. And the distance from negative 41 to 0 is 41 spaces. So we can write these one of 2 ways, going least to greatest. We can either show them in their original form, just like somebody had moved this little card up and laid it on the line. So these would be the numbers keeping their absolute value form, or we can show it as the simplified absolute value. It's good if you write them both, because that way you can match them up. You can look at this and say, oh, the absolute value negative 5, 5. Absolute value negative 7, 7. That might help you remember it for the future. Moving on to an example of absolute value. Well, an example of absolute value, since it is a distance from 0 on a number line, examples include number lines. So let's just do this. Examples of absolute value. And you could think of an example, you could think of a diagram. I'm going to show you 2. Here's the example of the absolute value of negative 3. So the absolute value of negative 3 is 3. Why is that? Because it is 3 spaces away from 0. just like the absolute value of 3 is 3 because it is 3 spaces away from 0. So each of those numbers has the same absolute value because each of those numbers is 3 spaces away from 0. On to number 4. On to number 5. In problem number 5, we've got Sophia. She's going to the store. She's buying some things that are on sale. 2 different items here. She's buying a jacket and she's buying some shirts. The shirts are on sale 20% off, and they originally cost $12. The jacket is on sale 30% off, and the jacket, she's buying one of those, costs $65. So we'll do those 2 things individually. Let's start with the shirts. Shirts are $12 each, and they are on sale at 20% off. All right, 0.2 or 0.20, however you want to show it. That extra 0 doesn't have any place. It doesn't hold a place. So 20% of 12 is $2.40. 10% of 12 is $1.20. 20% of 12 is $2.40. So on each jacket, she saves $2.40. Since she's buying 2 jackets, since she's spending that amount of money, she's buying 2 jackets, she's going to save a total of $4.80. So on 2 jackets, she will save $4.80. To get the cost of those 2 jackets, and let me just write this out and just add a little bit. $4.80 savings on, and it's on $24. That was $12 times the 2. And I said jackets earlier. I'm sorry. That was $12 times 2 shirts. So this is for the shirts. $12 a shirt, 20% off, $2.40. That is the savings per shirt. $2.40 per shirt times 2 shirts, $4.80 savings on $24. So to find the cost of the shirts, we have to take the $24, we have to subtract the $4.80 that she saved, and that gives us a price of $19.20. On to the jackets, the jacket. So on the jacket, she has a $65 cost, and on this one, she gets to save 30%. All right, right here we've got a 30% savings, so that's 0.30. We can bring it down as 0.30, or we can bring it down as 0.3, since that 0 that I drew in red does not have any place value. It doesn't hold a place. So $65 times the 30%, I think I'll grab my calculator for this one. $65 times the 30%, she saves $19.50. That's how much she saves, $19.50. To figure out how much she has to pay, what's the cost of the jacket, we're going to take the $65, we're going to subtract the $19.50, and we're going to get $45.50 left over. Now to figure out her total cost, the cost of everything, we've got the $45.50 that she spent on the jacket. We have the $19.20 that she spent on the shirts. And so all together, we have $64 $64.70 is the total amount that Sophia paid to get the 2 shirts and the 1 jacket. All right, on to the last problem. So our last problem, the last problem deals with Jackie. She's a waitress, and like most waiters and waitresses, she earns most of her money with tips. In Jackie's case, on Saturday night, her customers spent $1,200, and of that $1,200, she averaged an 18% tip. So she averaged 18%. So let's start by figuring out how much Jackie earned that night in tips. If she had $1,200 and she averaged 18%, the $1,200 times the 18% gave her $216. So she made $216 that night in tips. Now what Jackie does is Jackie tips the busboys out of her money. She knows that if the busboys work harder, work faster, get more tables opened up, then more of her customers can sit down and she's going to make more money. So Jackie tips the busboys out of the money that she makes. So she takes the $216 that she makes and she tips each busboy 2%. So each busboy gets 0.02. That's 2%, so 2% is equal to 0.02. So if we take the 216, it's still on our calculator, we multiply that by 0.02, we can see that each busboy gets $4.32. So tip for each busboy, $4.32. Since the question is, if she had 3 busboys that worked that night, how much did she have to pay out? Basically, how much money did Jackie share from her $216? Well, she shared $4.32 times 3 busboys, 6, 9, 12. She shared $12.96 altogether. All right, let's just go to the bottom of this page and show you what that last question's answer was. When you look at that last question, it says, what value makes the following inequality? Less than and greater than signs always create inequalities. What makes the inequality true? What value of x out of this list, which value of x makes x is less than the -4? Well, -1's bigger than -4. 7's bigger than -4. -6 is less than -4. -4 is equal to, so if you did signs next to these, -1 is greater than -4. 7 is greater than -4. -4 is equal to -4. The only one that's less than -4 is the -6. All right, there you go. Watch this video before we take the next test, and if you have questions, be sure to ask.